So batteries. We're surrounded with batteries. This drone has a 2-cell battery somewhere. This tiny drone, whoops, has, well, a tiny battery, which is actually obsolete now. It's not working. And today we want to get a good understanding of batteries, but not as a theoretical subject. This talk is not for electrical engineers who are experts in the chemistry or in the physics of batteries, but it's more about how we use batteries, or what is the role or the goal of batteries within some robotic system. Let's start. First of all will be the non-chargeable batteries, or the prime batteries, or simple batteries. And those batteries are usually expendable. You put them, you may try to charge them, don't do that. And they might get a little bit more energy, but once they manufacture and once they're gone, no more. Okay, those are the simple batteries. We have quite a lot of them surrounding us, but these days, often enough, you would like your batteries to be chargeable. So let's look at a chargeable battery. I think it's from a scooter or something like that. Not an electrical scooter, but just for starting it up. And each battery have a certain types of parameters. So we have a separate movie shows all the details and the numbers and illustration about batteries. But to keep it simple, I would like each and every one of you to be able to understand the simple terminologics of batteries. So we have voltage. Most batteries these days are composed from several cells. Cells could be combined or in series or in parallel. Those are examples for single cells. Although cell is written in C, in most examples you would see cells marked in S. So this battery is composed from 3 cells in series, but it's marked as 3S. This is a little bit confusing, but once you get it, it's okay. So those batteries are single cell. Other batteries I have here are 2 cells, 3 cells, and more than that. Now, if I'll take this meter and I'll try to measure this battery, it says all, and now it says each of those cells. Let's see again. So all is 11.5. First cell 3 point something, the other one 3.48, whatever, 3.86. Because they're connected in series, then you add the numbers. So we know the volt. A single cell of LiPo is mostly about 3.7 or 4 volts. If you have multi-cell battery, meaning they're connected in series, then basically this battery is a 3-cell. You multiply 3 by the voltage, which is 3.7, and it's written 11.1. This is the average. If you look at the bigger battery, this one is a 12 volt, but when fully charged, it's about 13.5. When totally discharged, you don't want to go below maybe 11.5 or so. Right, so there are different chemistry. I will not get into the chemistry of batteries. Those things are a topic of a lot of research. The electrical vehicle industry is pushing the manufacturers, Sony, Panasonic, and others of the manufacture of batteries, towards a cost-effective battery. Yeah. Now you may think of an electrical car. It may have thousands of those batteries connected in series and in parallel, and then you want them to be as efficient as possible, but also cost-effective. If you take an example, this battery, which is one of the most popular batteries in the world, it's called 1865 or 18650, which is 18 the diameter, and 665 will be the millimeter length of the battery. Those types of batteries are used all around, from flashlights towards your laptop. The bigger laptop may have those, drill machines, and electrical cars. Also satellites. Actually, in this little drone here, this is manufactured by DJI, you see the shape of the battery. It's actually 2 of those connected. Batteries has, as mentioned before, they have amount of energy or a capacity within them. When they fully charge, this battery has 3,000 milliamp hour. When it's half size, it will be 1500. First, let's assume I fully charge that. Now I start discharging it. I connect it to a machine, say that requires a constant 1 hour amp from that battery. After a while, I can test its voltage, and from that to approximate its initial or its current charge or state. Meaning, I want to correlate between the voltage and the amount of energy. Those things are quite common, and in very high-grade standardized batteries, those graphs are they're not necessarily linear, but they're close to that, and sometimes they're in this course we can assume they're linear, but in general you may think that I have a certain voltage, which is, say, in this example 4.2 volt. When it's fully discharged, it will be 3 volt, and in between them it's just a matter of linear interpolation.